Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Shawn Varney.
Hey everybody, welcome to our Tech to Tech series on case studies. The topic I'll be talking to you guys today is going to be about solutions for acid buildup in a vacuum degreaser. Why? Well, when cleaning involves the removal of chlorinated and brominated oils, coolants, and corrosion inhibitors, this may cause an acid concern. Sometimes we don't even know if we're creating acid, even if we have a concern or not. So our opportunity here with this customer was really to neutralize the acid that was being created in the chemistry inside the customer's machine. This customer was cleaning medical instruments, implants with a modified alcohol solvent. It's a metal NOx product, M6386, and they were using their vacuum degreaser. You know, if you want to learn a little more just on vacuum degreasers and operation, how they work, just visit our Tech to Tech series for more in-depth detail of how you can do this on KYZEN.com. So you'll see in the pictures here that, you'll have a front end, the bottom left, the loading bay right here of the vacuum degreaser. You'll have the back side, maintenance side, and this is where the panel's off. There's a lot that goes along to it, and then the working chamber. So I just want to caution you with this. Acid formed within a vacuum degreaser can cause very severe and expensive damage to the stainless steel and or copper components inside the machine. Also, a side note here, solvents alone don't have a pH, so water must be added to the solvent to pull the acid to be measured in a pH through a known process. So one of the challenges here that we came across when many questions and challenges arose, like how do we test for acid? Well, KYZEN has a acid stabilizer kit called ASK86, and this is the known process how to pull and test that sample. You'll see on the bottom two left-hand side, this is going to be your process on how to do it, and then it gives you a chart based on how many drops it is to neutralize it, and it tells you how many gallons versus ounces you need to add of neutralizer. On the top right here, you'll see that there is flood tank 1, flood tank 2. It's a water separator, and the distillation tank, which is short for disty. The disty we only tested for NVR, non-volatile residue, to see how loaded it was. You'll see the ASK kit, how many drops it took to neutralize it. You'll see the pH that correlates with that chart. And the water content, you're always going to have a little bit in there, just because that's how you measure the acid. The key ingredient to neutralize this acid really was Booster 86, as it's made for acid protection. You can see the pH of this is higher, to bring it back up to a more neutral or higher state is 11.1. It's got a high flash point and boiling point. It is water soluble. So the challenge here really is to bring the pH back to a more neutral or alkaline state of around 7 or higher. We needed the customer to sample for acid more often. So what a normal operation looks like for testing would be maybe every 2 to 4 weeks. If you had a light acid concern, it would be every week. If you had a high acid operation, probably every 2 days, if you had a concern like that. What we also needed the customer to do is add Booster, that Booster 86, more consistently after taking the test samples. So for normal operations, you might add only 12 ounces to a 100-gallon tank. If you had a light acid concern, you would do maybe 32 ounces on a 100-gallon tank. And if you had high acid, it'd be 70 plus ounces of the Booster 86 in a 100-gallon tank. So where do you pull samples from? So the still is probably your best spot to pull it, because that's where the most amount of acid accumulation is going to be. You can pull a sample from really anywhere in the, from tank 1, tank 2, or tank 3. You'll see in the middle here that you can see how the operation, this is a simple flow diagram of how it kind of works with a working chamber. You'll see tank 1, tank 2, and tank 3, but really the still is where you want to go. What location do you add Booster 86 to? So since it's a closed loop system, no matter which way the system's working, you can add it anywhere you want. The best location still is the still. So that's where you want to add it. But if you add it in a filter housing or tank or any other spots and you played with it, it's still all going to recirculate in the same spot and get back to the still. So the process and the game plan that we came up with really was to take samples every other day. We had this customer had an on-site lab, which made it very easy for them to do their own process. But we took results with it, process within an hour. But if they didn't want to do that, they could use the Ask86 kit to test for acid there on site as well. We, based on that sample, we add the correct amount of ounces of the Booster 86 to these sorted locations and see if one location works better than another. What we found out is that no matter where we added it, it was still the same. Booster still worked consistently. And so really it was about, step 4 here was staying consistent with sampling and adding booster. The customer and I talked, every other day after the booster was added and kept a log of the events. We even involved the machine manufacturer to ensure that we're not missing anything and that we wouldn't have any warranty issues. So you can see on the bottom there was kind of some more test results of the places where we took samples from and the acid with the drops and their pH. So really the solution here was we started at 3.6 pH, and after 5 weeks, this is kind of the test results. Week 1, we're around 4, 4.5. After week 2, increased about 0.5%. Week 3, we jumped to 1%. Week 4, jumped 2%. And same thing with week 5, we jumped back up and we were above that neutral pH of 7. So after 5 weeks and forward, the customer backed off the testing slowly and started testing from every other day to once a week. And now we're back to testing once a month. They can do this by normal dosing of Booster 86. It's about 4 ounces a week for their operation and workload. Just a little bit as you go through and you do some maintenance if you're topping off the machine or whatnot. The biggest challenge is getting it back under control and staying consistent. You've got to add it on a consistent basis. You can't run out and then start that process over again because you're right back to where you were because the acid will eventually take over. Being a slight alkaline state of pH is not a problem. So you'll see after week 5, we're at 9.56. That's quite okay. It's fine to be in an alkaline state. You just don't want to be in that acid state. So in conclusion here, working side by side with our customer, we were able to solve their concern within a couple of months. Just make sure you're testing on a regular basis. If you have an acid problem, do not wait. You got to act on it. Don't hesitate to contact your chemistry provider or the machine manufacturer for help, as this can be devastating to the machine for sure, and your process and the components that are in there. So frequently asked questions on this topic, how often should I be checking for acid in my system? Really, for normal operation is every, 1 to 2 months. If you have an acid concern, you would do it every few days or weekly. We suggest upon startup that you always test because sometimes you don't know if you're cleaning with those chlorinated and brominated oils. So in every startup, definitely test for acid. Question 2 here, what happens if I'm not testing for acid? Well, you could lead into big problems and you could have internal components on the machine eaten away, even stainless steel. You could have ball valves go bad. You can have all kinds of things that even your washing your parts could be damaged too as well. So always test for acid, at least on a regular basis. It depends on your operation. I would test at least every month or 2. Question 3, do all vacuum machine processes produce acid? No, depends on what you're cleaning off. Remember when you're cleaning those chlorinated and brominated coils, coolants, or corrosion inhibitors, that's what causes the acid. But still test all the time. Question 4, how do I pull samples from my machine? So the machine should have sample ports all over. Many times we do have to add a sample port through a 2-ball valve system, not to break the vacuum. So the first ball valve would be to put it in a work chamber. You would close that, open the bottom valve to put it in a canister so you don't break the vacuum anywhere. and you take a sample the correct way. And that is it for my Tech to Tech. I will turn it back over to William. Thank you.
Thank you, Shawn. Thank you all for tuning into this Tech to Tech session. If you would like to discuss this topic further or have any questions that weren't answered during this session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.